Hey, what's up, guys? It is, I believe, Wednesday for this assignment. This is just the rock cycle in depth. We're going to go a little bit more into it. This is the last assignment you guys have this week. We'll pick back up with this when we get back from the break. But last class, yesterday's assignment, you guys watched a video. That was pretty interesting. It was the guy kind of going through and showing you examples of the rocks from the different parts of the rock cycle, kind of going through those things. Today I just kind of want to explain it a little bit more, kind of slow it down a little bit, because it's a pretty wild concept to think that the rocks here on Earth are the same rocks that have been here forever, right? And they're not necessarily the same rocks because they've had different combinations, they've been recombined, melted, mixed with new rocks, whatever. But all of those atoms and elements that have gone into making them, those are just being recycled over and over. So going to the next slide, we have the three different types of rocks, right? So we've got our igneous rocks, okay, which are those rocks that are coming from the volcanoes, okay? We've got our sedimentary rock, which is once that magma has erupted from the volcano, has cooled down to form a solid, and then from wind, rain, different types of erosion, that rock is broken apart into little bits. Rain and wind will carry that rock down. It makes its way to streams, rivers, lakes, and it just gets piled up and up and up, right? So we have the sediment that gets stacked and stacked and stacked, and we get those rocks that we can see those layers in them. And then the last type of rock is that metamorphic rock, and this is that rock where it's been under such intense heat and on such intense pressure that it has changed a little bit, right? So that sedimentary rock is those little bits of small rock, sand, pebbles, and those all get smashed together under all that pressure, and those become those sedimentary rocks. But then when they make their way down close to that mantle where it's so hot, they actually will change into that metamorphic. And metamorphosis, if you think about that, like that's what a caterpillar goes through to become a butterfly, right? So it's like a change. And then, of course, once it gets close enough to that magma, it gets pulled back down, melts into that core, or not the core, melts into the magma, and then recombines with whatever other, you got to imagine how much rocks are melted down in that magma, right? And then eventually it'll find its way out another volcano, and boom, it's an igneous rock again, and we start over. Okay, so just kind of looking at some igneous rocks. Igneous rocks are formed by magma and lava as it cools. Igneous rocks form in two different ways. So we've got rock that comes from lava and cools very fast and can be either very light and airy, or the rocks can be glassy. So a lot of times you can see those rocks that have like the air pockets in them, and other times like those lava rocks will be very shiny. And then rocks that come from magma are formed underground. They're oftentimes very hard and have more colors. So basically we have magma that makes its way to the surface and cools, or magma that cooled underground. So those are the two types. But igneous rocks are coming from the magma. The easiest way to think is you think like a lava explosion. Like you imagine like Hawaii, where the lava is just flowing into the ocean all the time. That's just like constantly new igneous rocks, right? From there, if we're imagining that same example of the Hawaii volcano just flowing into the ocean that cools, well, imagine the tide and the waves are smashing into those rocks over and over and over, right? Birds are landing on them, whatever the case may be. Little pieces are getting broken off over time, right? So broken off, they get pulled out into the ocean. You imagine the ocean's nice and sandy, right? Well, there's lots of sand stacked on stacked on stacked and stacked. Eventually, under all that pressure, that sediment starts to get compressed, right? Kind of like our video yesterday where we had all those broken starbursts and he smashed them all together. They get compressed, right? So sedimentary rock is made when sediments, sand, gravel, dirt, they're pressed together over time and they become rock, okay? They form in layers, so you can like oftentimes when you see, like you can actually see those different like cuts in the rocks, that's sedimentary rock, right? And we have to imagine that any of these types of rocks can be exposed to the surface of the earth, right? Like sedimentary rock, if it happens to be on a fault, right, and it's a convergent boundary where those mountains are being made, those rocks are going to start getting pushed up. So you're going to see that sediment, right? Same thing could happen with metamorphic rock too. So don't think there's only one type that we're going to be able to see. Metamorphic rock, these are rocks made from other rocks, okay? And these are the ones that have undergone that change, okay? So the metamorphosis, that heat and that pressure over time, they change that igneous or that sedimentary rock into a new type of rock, okay? And that's the way we're going to think about this, and that's why it's important that I said we can see all the types of rocks on the surface of the earth, right? Because this metamorphic rock doesn't only have to come from a sedimentary rock, like it could come from an igneous rock, right? Imagine if magma was formed underground, it cooled, right? Never quite made its way to the surface. That igneous rock at that point would be so trapped down there, more and more pressure, right? That could undergo metamorphosis as well. Or we could have the other way where that sediment on the surface just gets buried over millions and millions and millions of years, and then eventually that sedimentary rock gets pushed down, and then it would become metamorphic rock as well. Okay? But main thing here is that this is a cycle. Okay? Excuse me. This is a cycle. The igneous rocks get broken down over time. They become sediment. That sediment gets stacked on top of itself over time, becomes sedimentary rock. That sedimentary rock gets buried and gets pressurized and heated over time. It becomes metamorphic rock. That metamorphic rock gets sucked back down into the magma, becomes igneous rock. Finds its way out of a volcano, becomes igneous rock, boom. Sedimentary over time, it gets broken down, gets buried, it becomes metamorphic, makes its way out of a volcano, it's igneous, right? Over and over and over. So these things are going to be recycled, they're going to be recombined, it's going to be not the same rock over and over, but the rocks have been rocks for billions of years, right? They might have been magma, but they're going to be rocks again, right? And magma still is rock. That's the important thing to think of. It's just liquid. So when we think of that magma, it's not like super hot water, right? It's super hot rocks. So that's crazy, crazy, crazy hot, crazy powerful, crazy strong. Okay? So like I said, we'll jump back into this when we get back from the break. Thursday, Friday this week, I'm just asking that you guys get caught up on any missing assignments. I know a lot of you guys are rocking and rolling, but a lot of us still have some missing assignments, and I just want to provide an opportunity for those students to get them done. So if you are done, you are caught up, you can hop into Minecraft, you could do Tinker for a little bit, or work on stuff for another class. But hope you guys have an awesome break. We'll see you when you get back. Peace out.